This is the last of our SLO9 videos. We're going to cover Chapter 15, all the non-parametric tests when we don't get to use the tests we've been learning about in Chapters 9 and 11. Which tests have we learned so far? Well, first we've learned the one-sample z-test. That's kind of an unrealistic test, right? We learned about that in 9.1 and 9.2 when we know the population standard deviation sigma. We also learned the much more realistic one-sample t-test when we don't know the population standard deviation sigma. We also learned two different kind of two-sample t-tests. One is when we have independent samples, and we learned about that in 11.1. We also, I'm calling this a two-sample t-test, but it's really for matched pairs, so in a certain sense, it's one sample data if you just consider the difference column, right? Anyway, we learned about that in section 11.2, right? And recall that for all of them, we required large sample sizes, right? Or in the case of independent samples, we needed that both N1 and N2 are greater than 30. Or we needed that the populations are approximately normal, right? So, right, if you look at these flow charts right here, right, that's when we get to use these tests, right, is when we have large sample sizes or small sample size, but from a normal population, right? Same with two sample data, right? When we have a large sample size or a small sample size from a normal population, we're good to go, right? As long as we're taking random samples. What we're going to look at today is, well, what happens when we can't use the tests, right? What happens when we can't use those tests? We have other tests we can use, and in a certain sense, they're more simplistic in that they use more simplistic machinery, like the median and positivity and negativity, that kind of thing, right? So, right, both z-tests and t-tests, right, offer samples that are either large or from approximately normal populations, right? Normal-ish populations, right? So what do we say when our samples are small, which means n is less than or equal to 30, and from non-normal populations? So what we do is we use tests that do not depend on the parameter mu. Hence, we call these tests non-parametric. For our first test, the sign test, we compare the median, m, not mu, just m, of our sample with the value in, that's an h null right there. Okay? Right, and we do z-scores, p-values, etc. So let's see what we do here, right? We've taken 12 random gas price samples. Right, we've taken a sample of 12 random gas prices, right? And we want to know if the median gas price is less than $3, right? Now note that they said the median, right? So what's the null hypothesis going to be in this case? Well, it's going to be that m equals $3, right? And then the alternate hypothesis is that the median is really, or the population median is really less than $3, right? So compute the test statistic, right? It's going to be the median. So it's just going to be the sample median, right? So the sample median, right? I think we could kind of look this up, right? Just pause the video and do it yourself. It should wind up being $2.84. I remember, it does take a little bit, right? You have to order the data and look for the point right between the 6th and the 7th in this case, right? Okay. So anyway, how do we find the critical value? What we're going to do is, again, we're going to do this one by hand. We'll do all the other ones in Minitab, but we get our book open. And we go here. Hopefully we have that. Excellent. All right, and we're going to use the table. Let's see. No, it's not quite the one. Let's see right over here. Students T, science. It looks like it's table A7, okay? So what we do here, right, we have, let me just screenshot that. note that the leftmost column is n, right? That's what we're working with, right? That's the number of things that we sampled. So let's go ahead and just put that in here, right? So what we have here, this is for part C, of course, is we have n equals 12, right? And we're doing this at the 0.05 significance level, right? So that looks like it's over here. So it looks like that's our number 2. Now, what does that mean, 2? Well, what we're really doing here is we're comparing these individual values to our hypothesized median, right? And we're just seeing, are they less than $3 or are they more than $3, right? So let's just look. We'll say if they're less than $3, we use a minus sign. If they're more, then we use a positive sign. So I'll just say for each data point, write a minus sign if it's less than the hypothesized median, which in this case is $3, and a plus sign if it's more than $3. Okay? Now, you don't literally need to do all that, but you can if you want, right? You do 11 minus signs, right? I'll just write one plus sign, right? You see that that's what we have, right? Because there's only one data point that's above $3. We ignore the zeros, by the way. If something is exactly equal, we'll just ignore it. All right, and what this says, what this on the chart says, is that we can have, if the lower number is less than 2, then it's statistically significant. So if the lower number of pluses or minuses is less than 2 in this case, then reject the null hypothesis. Right? So what's our conclusion? I'll write this in red here. Since we have 1 plus sign and 1 is less than 2, I'll use green for this. Reject the null hypothesis. So likely the median gas price is not $3. Okay. So now here's how we would do this in Minitab, right? It's good to know what we're doing, right? It's good to know what we're doing, but like, let's be real. Let's use Minitab, right? So anyway, median weight loss drug program, lose at least 15 pounds, right? That's sort of what I'm getting from this. I want to try to lose at least 15 pounds. They take a sample of 20 people. Can you conclude that the claim is false? Now, let's be a little careful. What would our null and alternate hypotheses be? Well, the null hypothesis is that the median, again, it's median, right? The median weight loss is going to be, not dollar sign, 15 pounds, right? The alternate hypothesis, I would say, since they want us to lose at least 15 pounds, right? I would say that the alternate hypothesis should be that the median weight loss is less than 15 pounds. Okay, do you see why? Right, compute the value of the test statistic, critical value, state the conclusion, right? Let's see what we've got here, right? If we go into Minitab, where I've already entered this data in, right? I've entered all 20 data points, etc. So we're going to go to stat non-parametrics, one sample sign. Yeah, this is where our variable is going. Right, I guess I should check what is our confidence level. Okay, it's still the 0.05 significance level, okay? So our confidence level will be 95, right? 100 minus. Now, what are we going to put for the test median, right? Actually, sorry, forget the confidence interval. We're not doing that. I lied. Our test median is going to be 15, right? And what's our alternative going to be? Well, it's going to be less than, right? So let's see what happens when we do this. Right? So the number, so you see how they divide it into less than, equal, and greater than? So a lot of people lost less than 15 pounds, and very few lost more. So the p-value is so small it doesn't even appear, right? So let's put this in here, right? So I'll just say sample median is 8 pounds. Okay, find the critical value. The critical value was actually, let me even see if do we even need the critical value really. We can ignore that for right now. We could use the chart to find the critical value, right? Since we have the chart open, right? For n equals 20, and we're doing one-tailed, right? Critical value would be 5. So I'll just say, using the table, critical value is 5, right? Right, since only 2, which is less than 5, people lost more than 15 pounds, reject the null hypothesis, right? So this drug is not that effective, right? Okay, so that's how you do it, right? You also could have said, I guess you could say, alternatively, actually, no, I won't even say that. Forget I said that, right? That's all we're going to do. Okay, never mind. Okay, so anyway, we're going to go to the next test now, right? The rank sum test. Right, suppose you've got 1 or 2 populations that are not normal and whose random samples are small, which means n is less than or equal to 30, right? So now we're considering 2 sample data. Okay, so we can't use the paired t-test. We can't use independent, right? Because we're just right. We can't use t-tests in general, right? So we have to use something else. So the rank sum test, or there's another. I think it's called the Mann-Whitney test. I guess I should just say the rank sum, right? Right, and so it uses, let's see, sample medians, right? To estimate whether 2 population medians are equal, right? So here's what we're doing, right? So this one, I'm just going to use mini-tab, right? 14 students took online. Another sample of 12 took traditional. But you see how they're small. You could just look at their graph of their test scores, see they're not from normal populations. Let's see what we're doing here, right? Can you conclude that there's a difference, right? So I guess we should start off by hypothesizing. We should say that M1 minus M2 equals 0. The alternative hypothesis would be that M1 minus M2 does not equal 0, right? Because they just said the word difference. Okay? So let's find out. So we do this test. Let's see what we do, right? We go to Minitab. I went ahead ahead and entered all the data, right? 14 points for online, 12 for traditional. Stat, non-parametrics, we're going to do Mann-Whitney, right? It's called Mann-Whitney, right? So first sample, we'll do online. Second sample, we'll do traditional. Right, and here we will just keep the confidence level at 95 because they used it a 0.05 significance level. Alternative, and we are going to keep it at not equal, right, because they just asked for a difference, right? Right. And so you see here, right, we have our confidence interval, blah, blah, blah. They have this whole not adjusted for ties. Adjusted for ties doesn't make a difference, right? See that p-value, 0.719? Goodness gracious. Right? So if we go back here, we'll say using Minitab, we get p-value, p equals 0.719, which is significantly greater than alpha equals 0.05. So, fail to reject the null hypothesis. So, there's not enough evidence of a difference in median test score. Okay. That's it. All right, next up, signed rank test, right? So suppose, again, we have a small, which means at most 30, sample from a population that is not normal, right? And suppose further that we have paired samples, right, instead of independent samples, right? Paired data, right? But we can't use the paired t-test because the populations are small and not normal. However, we can use the signed rank or Wilcoxon test. All right. And, you know, there's a whole way to do it in the book. It's really not that bad, but it is several steps. So let's just use Minitab. Let's just use Minitab. Entering all the stuff. Remember, it's paired data. Better have the same number, right? Stat, non-parametrics, one sample Wilcoxon. Oh, shoot, sorry. Before we do that, I need to do something here. I do need to call this difference. Right, okay, I do need to do this because we do need to create, you know, the one column and everything. So then we go, I guess, calculator, and we're going to store this in the difference, right? And we're just going to do, you know, this guy minus that guy. Bam, those are differences, right? Okay, so stat, non-parametrics, one sample Wilcoxon. So now we get to use this difference column that we created, okay? Okay. Now, on the one hand, you could use the confidence interval of whatever they wanted, but let's see what they say. Each student took a pretest. Can you conclude there's a difference between pretest and post-test, right? So maybe before we even crunch the numbers, let's write our hypotheses down, right? So we have, I guess we'll say M1 minus M2 equals 0. Alternate hypothesis, M1 minus M2 does not equal 0. So we use Minitab. Let's see what we get. Test median, we want it to be 0. Alternative, not equal. Let's see what we get. So you see how our p-value here is 0.019? Using Minitab, we see that p equals 0.019, which is less than alpha, which equals 0.05. So we reject the null hypothesis. So there is enough evidence of a difference. Okay. Now, just really quickly, right? A drawback to the Wilcoxon test. This I should also say is, when do we get to use the Wilcoxon test? I should also add that, one sec. We do require, I'll write this up here, that the population be roughly symmetric, right? Doesn't need to be normal, it could be bimodal, but it needs to be roughly symmetric, right? So that's drawback number 1. But drawback number 2, when the sign differences are close to being normally distributed, Wilcoxon test is less likely to reject a false null hypothesis than the t-test. So that's just one thing to watch out for, right? So let's just very, very quickly review what we've got here, right? Given a small, n at most 30, sample from a non-normal population, if we want to estimate the median of the population, then use the sign test. If we have paired sample data, want to estimate the difference between the medians for a population, then use the signed rank or Wilcoxon test. Give her 1 or 2 small samples from 1 or 2 non-normal populations. If you want to estimate the difference between I should make that a little neater. Between population medians, then use the rank sum or Mann-Whitney test. Okay. So one little activity you can do, try to draw a little flow chart of all this. Okay? That's all.